In previous video, we have discussed about heat and temperature. Now you know what is heat and what is temperature. Yes. So let us know now what is the difference between heat and temperature. To know the difference between heat and temperature, let's do an activity. Just take a container. In that container, take some water and heat that water up to 60 degrees Celsius. Yes, first take a container with some water and heat that water up to 60 degrees Celsius. So after taking that water in a container and heating it, what you have to do means just take a cylindrical transparent glass jar. What you have to take? A cylindrical transparent glass jar. So after taking this cylindrical transparent glass jar, what you have to do means just pour that hot water into this jar. Fill that water into this jar. So after filling this jar with that hot water, what you have to do means you have to pour some coconut oil on the surface of this water. You have to pour some coconut oil on the surface of this water. Yes, after filling with this hot water and with this coconut oil, just keep a lid. Just cover the jar with the help of the lid, and that lid should have two holes. That lid should have two holes. Through that two holes, keep two thermometers. One thermometer should be inserted into that oil and another thermometer should be inserted into that water. Yes? Yes. So, this is hot water and this is oil. And these two are thermometers. Yes. So first what we have to do, we have to take a transparent glass jar. In this transparent glass jar, you have to pour that hot water. After pouring that hot water, you have to pour some oil by covering the surface of that water. After covering the surface of the water with the oil, what you have to do, you have to cover this jar with the help of that lid. And that lid should have two holes to insert thermometers. Yes, that lid should have two holes to insert two thermometers. So, if you observe the readings of the thermometers, if you observe the first thermometer's reading, what happens? The thermometer which is inserted into the oil, its reading will be increased. What happens to its reading? Its reading will be increased. But when you observe, the reading of this thermometer will be decreased. It will be decreased. Why the reading of the first thermometer will be increased and why this thermometer which is inserted into the water, that reading will be decreased? Let us see. Yes, what's happening? So what happening means, when you take the first thermometer, it's having the temperature at room temperature. This oil is having room temperature. But if you see this water temperature, what is this water? It is a hot water which is boiled at 60 degrees Celsius. So when you boil this water at 60 degrees Celsius, what happens? Which one is having higher temperature? Water is having higher temperature. Yes or no? Already you know, heat flows from a body at higher temperature to a body at lower temperature. Yes? Yes. So So here what happens, from where to where heat flows? The heat flows from a body at higher temperature, means at water. From water to a body means to oil. That means heat flows from water to oil. Yes. So when heat flows from water to oil, what happens? Water will lose its heat energy. When it is going to lose its heat energy, what happens to its reading? Its reading will be decreased. Yes or no? Yes. So when heat energy is going to be transferred to the oil, what happens? Its reading will be increased. Yes, it is gaining some heat energy from the water. So when it is gaining heat energy from water, what happens? Its reading will be increased. Yes, all of you understood? Yes. So when heat energy is being transferred from water to oil, what happens? The reading of the water will be decreased and reading of the oil will be increased. Yes. So here if you observe, what happened? Heat. Already you know. Heat is a form of energy that flows. That's it. Heat is a form of energy that flows. But what about temperature? Temperature determines the direction of flow of heat. Here what happening? The heat flowing from where to where? From higher temperature to lower temperature. That what it indicating? That indicating that temperature is indicating that it flows from higher temperature to lower temperature. No, heat is being flown from higher temperature to lower temperature. That means the temperature is determining the direction of the heat flow. From where to where it is going to flow, it is being determined by whom? By the temperature. Yes or no? If it is having temperature only, it is going to flow from higher temperature to lower temperature. Yes or no? Already we know what is temperature means. Temperature is a measure of degree of hotness or degree of coldness. That means it is going to determine the direction of flow of heat. But heat is determining what? It is a heat is an energy that flows. That's it. So what is the difference between these two means? From this activity what we can conclude means, we can conclude that heat is a form of energy that flows and temperature determines the direction of flow of heat. Now let's see about next concept, specific heat. What is specific heat? Specific heat is nothing but it is a property of substance. What is specific heat? Specific heat is nothing but it is a property of substance. To know more about, let's do an activity about it. Yes? Yes. So firstly we have to take a large glass jar which is containing water. Yes? So firstly we have to take a large glass jar which is containing water. After taking the glass jar, just take a retort stand which is having one rubber cock to hold the test tubes. Yes, what you have to do, you have to take a retort stand which is having one rubber cock. Yes. So what we have to do, we have to take a retort stand which is having single rubber cock to hold the test tubes. to hold the test tubes. Yes, yes. So firstly what we did, first we have to take water in a glass jar. Next take the retort stands which is having a single rubber corks. With this rubber corks what we have to do, we have to hold the test tubes. Yes, yes. So in one test tube take 50 grams of oil, and in this test tube take 50 grams of water. Yes. In the first test tube we have taken 50 grams of oil. In second test tube we have taken 50 grams of water. These both are at room temperature. This oil and water which is present in test tube, they are at room temperature. But the water which is present in jar, it should heat up to 80 degrees Celsius. It should be heated up to 80 degrees Celsius. The oil and also the water which are present in test tube, they are at room temperature. But the glass jar which is containing water, it should be heated up to 80 degrees Celsius. Yes? Yes. So, both these test tubes should be kept in this water only. Yes? These test tubes should be kept in this water only. Yes? Yes. So, now keep a thermometer into the test tube. And also another thermometer into this test tube. Yes. Note down the readings of the thermometers. Yes. So, in which test tube does the temperature rise quickly? Yes. Both are having equal mass. It is 50 grams and it is 50 grams. And heat supplied to these test tubes is 80 degrees Celsius. To the oil test tube we are supplying 80 degrees Celsius, and to water test tube also we are supplying 80 degrees Celsius. So if you compare these two test tubes, which test tube does the temperature rise quickly? Yes, oil temperature will be raised. Why? Because the average kinetic energy of the oil molecules will be increased. Yes, the average kinetic energy of the molecules will be increased. Which molecules? Oil molecules. But here the average molecule, the average kinetic energy of the water molecules will be decreased. Yes, yes. So the average kinetic energy of the water molecules will be decreased, and here the average kinetic energy of the oil molecules will be increased. So that's why if you observe, the temperature of the oil will be raised quickly. But when this test tube is having water, it will be decreased because the average kinetic energy of the water molecules will be decreased. Yes, yes. Though they both are having equal mass and though we are supplying equal temperature, why oil is being increased and water is being decreased? That means the raising of heat will be depends on the nature of the substance. Yes, the first property, what is the first property to raise the heat means the first property, it is nature of substance. Yes. Heat raising depends on three properties. What is the first property means? It is nature of substance. Here we got oil. Yes. And here what we got? We got water. Yes. So when you take different substances, what happens? The raising will be different. Yes, in oil, the raising will take quickly, but in water, the raising of temperature will be slow. It is being decreased, but here in oil, it is being increased. So, the raising of heat will be depends on nature of the substance. Yes. So, let's see about other activity. To see that activity, just take 2 beakers. In one beaker, just take water. It is 250 grams. Yes. And in this beaker, it is going to contain 1 liter. Yes. In first beaker, we are taking 250 grams of water, and in second beaker, we are taking 1 liter of water. Yes. Here we have taken in both beakers water only. There is no different material here. Here both are water only. But here 250 grams of water and here 1 liter of water. Then supply some heat to it. Yes. Just supply some heat to it. How much heat you should supply means it is 60 degrees Celsius. And here also you supply 60 degrees Celsius. Yes. Yes. So here we have to supply 60 degrees Celsius to each beaker. To the first beaker you have supplied 60 degrees Celsius, and to the second beaker also you have supplied at 60 degrees Celsius. But the first beaker, how much quantity it is going to have? It is going to have only 250 grams, and here it is having 1 liter of water. Okay. So here we taken water only. Here also we have taken water only. Yes, we are having same material and same supply of heat. Same amount of heat is being supplied. But what happened here? The quantity, the mass of the substance is different. Yes, yes. So the mass of the substance is different. That's it. So now, in which beaker the rise of temperature will takes place quickly? In which beaker? In 250 grams of water. Yes, though it is having less mass, what happens? It rises fastly because we are giving 60 degrees Celsius. Here 1 liter of water is there. To raise it, we have to supply more heat when compared to this. Yes, yes. So here we have to supply more heat. That's why it is going to take some more time. But here only for 250 grams of water we have supplied 60 degrees. So it is more enough to it. So what happens? If quantity is less amount of heat is required to raise the temperature. But if quantity is more, then more amount of heat is required to raise the temperature. Yes. So which quantity, which beaker is going to have more raising of temperature? 250 grams of water beaker raises its temperature quickly because it is having less water, but it is having high amount of heat energy. Yes. So by this what we can say, the raising of heat can also be depends on mass. If it is having less mass, less amount of heat is required to raise its temperature. If it is having more mass, then we have to supply more amount of heat energy. So what is the first property? It is the nature of substance. Based on the nature of the substance, we can raise the temperature. And here which one? The second property is mass. Based on the mass, the raising of the temperature will takes place. Yes. So let's discuss about last property. What means? From this I will explain you. Just here also take 1 liter only. Yes. So let me rub it. So in both beakers we are taking 1 liter only. Yes. And here just supply 30 degrees. Yes. So in both beakers now we are having same amount of substance. Yes. 1 liter of water and 1 liter of water. But supply of heat is different. To first beaker we are going to supply 30 degrees Celsius and to second beaker we are going to supply 60 degrees Celsius. So when you supply 30 degrees Celsius to 1 liter, will it raise its temperature quickly, or else when you are supplying 60 degrees Celsius of temperature to 1 liter, will it raise quickly? When you are supplying 60 degrees of temperature to the 1 liter of water, it will raise quickly. Yes or no? Yes. Yes. That means when there is a more amount of substance, what you have to do, more amount of heat energy should be supplied. But here what happened? This more amount of substance we have taken, but what happened? Less amount of heat energy is being supplied. So then it takes time to raise its temperature. Yes or no? So which one is going to raise its temperature quickly? This one will raise its temperature quickly because we are supplying more amount of heat when compared to this. So the third property, it also depends on supply of heat. It is a third property. It also depends on supply of heat. Yes. So the heat raising, yes, the raising of heat depends on three properties. What are the properties? First one is nature of substance. When we taken two different substances, the raising will be different. And here, when we have taken different mass, the raising of the temperature will be different. And when we supply heat, when the supply of heat is taking in different amount, then what happens? The raising of temperature will take place in different. Yes. Yes. So these are the three properties of raising of heat. Yes, the raising of heat depends on these three properties. Yes. Yes. So then what is specific heat? Let's see about it. Yes. Heat is denoted by Q. Yes. Heat is denoted by Q. So when heat is being raised, its temperature or its mass also, yes, its mass also is being raised. That means heat is directly proportional to mass. Yes, heat is directly proportional to mass at a constant of change in temperature. Delta T is representing change in temperature. Yes, Q is directly proportional to mass. That means heat is directly proportional to mass. Yes, when you are going to take more amount of heat, you have to take more amount of mass. If you take less amount of heat, less amount of mass you have to take. So Q is directly proportional to M. At delta T means change in temperature. So you are taking a change in temperature as a constant. Okay. Next again, heat is directly proportional to change in temperature at a constant mass. Yes. Yes. So when you are taking same mass at a different temperature, it is directly proportional to heat. Yes. So if you take same mass, that means constant mass you are going to take 1 liter constant mass. But here change in temperature. Yes, you have taken change in temperature. When you are taking change in temperature, it is also directly proportional to heat. Yes. Yes. So from these two equations, what we can conclude means, we can conclude that Q is directly proportional to M into delta T. Yes, from these two equations, what we can conclude? We can conclude that Q is directly proportional to M into delta T. Now, Q is equal to S into M into delta T. What is this S? This S is constant. What is this S? S is constant. Constant, it is nothing but specific heat. Constant, it is nothing but specific heat. Yes. Q is equal to S into M into delta T. Yes. Yes. S means constant. This constant is nothing but specific heat. From these equations can we write as S equal to Q by M delta T? Yes or no? S is equal to, that means S is equal to Q by M into delta T. Yes, S is equal to Q by this M and delta T will come into denominator. Yes, S equal to Q by M into delta T. That means where specific heat is equal to Q by M delta T. What is the formula of specific heat? Formula of specific heat is S equal to Q by M delta T. If you observe, Q is directly proportional to M and Q is directly proportional to delta T. But coming to here, specific heat is inversely proportional to delta T. Yes, specific heat is inversely proportional to delta T. S is inversely proportional to delta T. Yes, so S is inversely proportional to delta T. That means if you take a substance, if it is having higher specific heat, it can't be heated. Yes, if you take a aluminium wire, yes, if you take a aluminium wire, aluminium will be having higher specific heat. Its value is 822 joules per kg into Kelvin. Aluminium is having specific heat of 822 joule per kg into Kelvin. When it is having higher specific heat, if you want to heat that aluminium, is it possible? No, we can't heat it, because though it is having higher specific heat, it cannot absorb heat. Yes, so if specific heat is higher, the temperature of that substance is lower. Yes, if that substance is having higher specific heat, that substance temperature will be lower. It can't absorb temperature. Yes, okay. So what are the units of specific heat? The SI unit of specific heat is joule per kg into Kelvin. Joule per kg into Kelvin. Or else you can also write it as joule into kg inverse into Kelvin inverse. Yes, the SI unit of specific heat is joule per kg into Kelvin, or else you can also write it as a joule into kg inverse and Kelvin inverse. Next, let's see CGS unit of specific heat. Yes, what is the CGS unit of specific heat? Calorie. What is calorie? I told in your previous video. Calorie by grams into centigrade. Yes, calorie by gram into centigrade. Or else you can also write it as calorie into gram inverse centigrade inverse. Yes, the CGS unit of specific heat is calorie by gram into centigrade, or else you can also write it as a calorie into gram inverse into centigrade inverse. Yes, what is the formula of specific heat? Specific heat is equal to Q by M delta T. What is its formula? Q by M delta T. If you observe from this formula, we can know that specific heat is inversely proportional to difference in temperature. This delta T is representing difference in temperature. So S is inversely proportional to difference in temperature. And when a substance is having higher specific heat, what happens? It absorbs less heat. We can't heat that substance. So what are the units of specific heat? SI unit of specific heat is joule by kg into Kelvin, or else you can also say that joule into kg inverse into Kelvin inverse. And next, CGS unit of specific heat. What is the CGS unit of specific heat? Calorie by gram into centigrade, or else calorie into gram inverse into centigrade inverse. Okay. So now let's see what is the definition of specific heat. The definition of specific heat is specific heat of a substance the amount of heat required to raise temperature of unit mass of a substance by degree centigrade. What is the definition of specific heat? Specific heat of a substance, the amount of heat required to raise temperature of unit mass of a substance by degree centigrade. Yes, the amount of heat required to raise temperature of unit mass of that substance by the degree centigrade. It is the definition of specific heat. Yes, so in this class you have learned about how to know the difference between heat and temperature and what is specific heat by doing these activities. So if you like the video, for more updates, just subscribe to my channel, like, share and comment me down.